Hello, my name is Avinash and I am going to do a seminar on bandwidth and latency. Network performance is measured in two fundamental ways, the bandwidth or throughput and latency or delay. The bandwidth of a network is given by the number of bits that can be transmitted over the network over a time period. For example, a network may have a bandwidth of 5 million bits every second, meaning that per second it can deliver only 5 million bits. Yeah, it is sometimes useful to think of bandwidth in terms of how long it would take to transmit each bit of data. For example, on a 10 megabits per second, how it would take zero point 0.1 microsecond to transmit each bit to transmit each bit, and bandwidth is literally a measure of the width of the frequency band. For example, a telephone line uh, supports a frequency band ranging from 300 to 3300 hertz, then it's said to have a bandwidth of 3000 hertz, 3300 minus 300. And bandwidth in this context is measured in hertz, and it refers to the range of signals that can be accommodated over a particular link. And the data rate is a measure of the number of bits per second that can be transmitted over a particular link or channel. And there's a difference between the maximum data rate of a channel and the number of bits per second one can actually transmit in a given channel. For example, in a 20 megabits per second network, one can only have one can only transmit 4 megabits per second and not more than that. So there's a difference between the maximum data rate and the number of bits per second that can be actually be in reality be transmittable. And throughput is nothing but a measured performance of the system. uh, if a second of time is thought of as a distance that can be measured with a scale ruler, and bandwidth as how many bits fit uh, in that distance, then each bit can be thought of as a pulse of having some width. For example, in 1 Mbps link here, uh, then each bit is 1 microsecond wide, while on a 2 Mbps link, the each bit is zero point 0.5 microsecond wide, half of this link here. And the more sophisticated, the more advanced the transmitting and receiving technology is, the narrower each bit can become, and thus enhancing the bandwidth. And for process-to-process channels, bandwidth is also influenced by other factors like the software that modifies and transforms each bit of data. If the software and the other factors it can modify and gauge the data, bits of data very well, then bandwidth also increases. Uh, Latency is a metric, a measure of how long it takes for a message to travel from uh, one end of a network to the other. And latency is strictly measured in terms of time, where bandwidth previously can be measured in hertz, and we also did like how it would in a particular 1 second, uh, 1 Mbps link, 1 microsecond with pulse of data. And unlike bandwidth being measured like that, latency is strictly measured in terms of time. And for example, like in a transcontinental network which has latency of 24 milliseconds, it takes a message 24 milliseconds to travel from one coast of that particular network, in this case North America, to another point in that network. And there are many situations like in of handshaking, where it is important to know how long it takes for you to send a message from one end of the network, and for the message to return back to the sender, rather than a one-way latency from sender to receiver. It is also important to know from sender to receiver and the receiver back to sender, and this is called as the round trip time of the network. Uh, uh, Latency can be thought of as having three components. There is speed of light propagation delay, where the light travels across different medium at different speeds at 3.0 10 to the power of 8 meters per second in vacuum, 2.3 10 to the power of 8 meters per second in copper cable, and 2 into 10 to the power of 8 meters per second in an optical fiber. And secondly, there's the amount of time it takes to transmit the transmit time to transmit a particular unit of data, and it's a function of the network bandwidth and the size of the packet in which the data is carried. If the network bandwidth is very high and the size of uh, packet is relatively less, or it can be accommodated, then the transmittable time would be generally less. Or if the size of the packet is more than what the network bandwidth is a little less, then the transmittable time would be less. The transmittable time would transmit time would be more actually. And thirdly, there may be queuing delays inside the networks, since packet switch, they need to store packets before forwarding them on outlook outbound links. Maybe they need to store packets to schedule them, or some priorities, or some or any other scheduling policy which may be unique from one network to another. And latency can be defined as propagation plus propagation delay plus transmit time and queuing delay. And propagation delay itself can be given by distance by speed of light, and transmit as earlier said, it's a function of size over bandwidth. And distance is nothing but the area of the medium which the data travels. The speed of light is the speed of light over that inform how the data travels over that particular wire. Size is size packet, and bandwidth is the bandwidth at which the packets is transmitted. The number of bits, a unit of data that can be accommodated, number of packets of data that can be accommodated at a particular amount of time. And if the message contains only one bit, and only in the case of a single link, then the transmit and queuing delay would not be there, because only one link, there would be no queuing delay for only one bit. It can be sent right off, and there would be no transmit delay also, because the size over bandwidth is the transmit delay, and in a single link one bit can be easily be sent through, and latency would hence be only correspond to the propagation delay. Bandwidth and latency are combined to define performance characteristic of a given link or a channel. Relative importance of either one of them, depends on application to application. For some application, latency propagates bandwidth, like in a client server model, where one client sends 1 byte message to a server, receives 1 byte in return. It is latency bound rather than bandwidth, because it would depend on the client, it would depend on the server receiving the message of the client, and then to send it back to the client, rather than the bandwidth to how the 1 byte message is actually being transmitted. And for a 1 byte object, like for the keystroke is pressed, and the latency here would remain almost equal to the RTT. Like latency, how if a keystroke is pressed, then for the message to for the 1 byte message to carry on that system, it is equal to the number of time the system responds to that immediately. So latency would be equal to RTT. So it's not possible to distinguish between 1.5 or 10 Mbps network or 15 Mbps network, because it would not remain relevant to that. For an email message for a 2 kilobytes, the link speed would make a difference on a 1 millisecond RTT network, but negligible on a 100 millisecond RTT network. And for again 1 megabytes object, like for digital image of PNG, GIF, the RTT makes no difference. It is the link speed that dominates the performance across the full range of RTT. The bandwidth here would it dominate over the latency here. And here we see the perceived latency versus the response time here. Uh, this figure here shows how latency or bandwidth can dominate performance in given different circumstances. As we had seen earlier, this is the graph of that, and the graph shows how long it takes to move objects of various sizes, one byte, 2 kilobytes, or megabytes for that matter, across networks with RTTs ranging from one one millisecond 1 millisecond to 100 milliseconds, and with link speeds here from 1.5 megabits per second to 10 megabits per second. uh, Delay into bandwidth product can be thought of that like as considering if a channel between a pair of processors if thought of as a hollow pipe between one processor and another processor, the length of the pipe here would correspond to the delay here, and the diameter of the pipe is would give the bandwidth, and this would represent the volume of the pipe, which would give the which would represent the maximum number of bits that could be in transmit that could be in transit that could be transmitted over the number of bits of data that may be transmitted at any given point of time, at any given instance of time. If latency in time corresponds to length of pipe, and width of each bit also in time, it is easy to calculate how many bits fit in that pipe. And delay into bandwidth the product, why at all we doing that, this is important to know when constructing high performance networks, because it gives an idea on how many bits the client, this is the sender, must transmit before the first bit arrives at the receiver. And if the sender is expecting the receiver to somehow signal that the bits are starting to arrive, like in handshaking, then it would take another channel latency, again one more latency from the receiver back to the sender, another latency for the signal to propagate back to the sender. Then the sender can send up to one RTT into bandwidth worth of data before hearing from the receiver that it's good that it can receive the data. The bits in the pipes are in transit, which means that if the receiver tells the sender to stop transmitting, it would receive up to 1 into RTT. The 1 into RTT it would receive nevertheless, because so when the receiver sends the sender back that it doesn't want it, does not go before the one before one RTT into bandwidth time. And here transcontinental we have one way latency of 50 milliseconds and the bandwidth of 45 megabits per second, and it holds one for it holds 280 kilobytes of data. Uh, Here see the different delay to bandwidth products for the different channels or different types of links here, where the dial-up or dial-up phone connection or modem, to connect the modem, the RTT to bandwidth is 5 bits, and for wireless LAN 18, and for satellites it's 10 megabits for, for satellite phone calls and such. And cross-country fiber is 400 megabits, where cross-country like trans-country or between continents, like that.